Hi friends, today you will learn the construction of shift reducer parser. This shift reducer parser technique is a bottom-up parsing technique. This method attempts to construct the parse tree from the leaf node to the root node. This process can be a reducing a given string w to the start symbol. That means that if I given a string w, so now we are going to be deriving that start symbol based on the backtracking procedure. That means that how we are going to be backtracking procedure. So for example, consider a grammar. So this is the grammar I have given. S tends to, so S tends to AAC BE, and A tends to ABRB, B tends to D. So this is the string I am going to be given. So now I'm going to be derive the start symbol based on the given string, backward procedure, from the given string to the start symbol S. So initially I am going to be read the set of characters available in the given string from left to right. So from I am observed that B is going to be replaced as per the production. A tends to B. A is instead of B, I'm going to be replace it as a A. Once again I observed that AB can be replaced as the production. A tends to AB production, then A is going to be replaced. Now once again so AB, actually it is an AB production that we have. AB is replaced as A. So now once again move the pointer towards the right side direction. So here the red color font tells about that. So what is the symbol that is going to be replaceable? Now we moving towards the right hand side direction. D is available. So as per the production, B tends to D. This is the hint I am going to be given here. D tends to B tends to D. So D is replaced as B. Once again A C B E, AAC BE we have. So AAC BE is going to be replaced as a start symbol S. So now we consider the string. We will reduce the string S. We can scan the string from ABCDE, ABBCE, ABBCDE from the left to right, finding the substrings that are matched with the right hand side. So like that we are going to be observing that some substrings that we have. So like that we are deriving that start symbol S. So generally by reducing the string W to the start symbol S in the reverse of the rightmost direction. Actually it is the reverse of the rightmost derivation. So generally when we are going to be talking about the implementation of shift reducer parser, a better way to implement the shift reducer parser is to use the stack and the input buffers initially. So we have to take the input stack is initially it is an empty, and the input string that is constrained with a set of strings that is nothing but W. So initially the stack contains as an empty, that is nothing, only dollar symbol tells about that, and the input tells about the set of strings followed by a dollar. The parser operating by shifting 0 or more input symbols from the on the stack until a handle or alphabet beta is on the top of the stack. The parser can reduce the beta to the left hand side by appropriate production whatever we repeated the above process until unless no more symbols are going to be added into the stack. So we have to be repeat that process until unless no more symbols. After completing this procedure, so then we can identify that stack is nothing but, so after the implementation of all the symbols moved into the stack, then the stack will be represented as like that. So the start symbol contains a start symbol S and the input is contains an empty. That means that the 0 or more symbols are pushed into the stack. So once the strings are pushed into the stack, we are going to be applying a reduce operation, and the stack contains start symbol S. So in my context free grammar, I am going to be treating as S. In this configuration, the parser halts and announce that successful completion of parsing string, and it is accepted. The shift reducer parser has mainly four actions that we have. So they are the four actions that we have. So one is the shift, reduce, accept, error. So generally shift means the parser shift the next input symbol to the onto the stack, move on to the one character by character moving to the stack. So reduce operation that is going to be done. The parser identifies that some handle beta, it can be replaced by the left hand side production. So in left hand side appropriate production, that means that whatever the production that we have, so instead of right hand side production, we are going to be replaced with the left side production, replaceable part whatever we have. So coming to the accept, the parser halts and announce that successful completion of the parsing is over. That means that the construction is over. So move on to the next type of action, that is nothing but error. The parser discovers a syntactic error and calls the error routine for error recovery. Whenever the error is occurred, then the situation tells about that the parser is going to not in a position to perform that parsing. That is nothing but the string is not belongs to that grammar. So like that we are going to be deriving the shift reduce parser. So let us consider with an example. For example, I am going to talk about a simple example. So here the grammar I am considered as, so E tends to S tends to S star S s tends to s star s tends to s plus s tends to id. So now I'm going to be applying the shift reducer parsing to derive the string for the input string id plus id star id. So here I'm taking as a parsing derivation contains three columns, like initially whatever I said, that initially stack is an empty and the input buffer that contains a set of string, that is the string w is nothing but id plus id followed by dollar. And the parsing action, each and every time we are going to be push one or more zero or more symbols into the stack. First I pushed the stack id into the stack, id is pushed, now the input buffer contains plus id dollar. Now id is going to be pushed as per the production s tends to id. If it is a production, beta is available, beta replaceable production in the right hand side is left hand side is nothing but s. So instead of id I'm going to be replacing an s, that is nothing but a reduce that production. So this is the shift operation, this is the reduce operation. So once again I am repeating that reduce operation. If s tends to id is the one production that we have, id is going to be replaced as s. So in the stack I'm going to be reduce that id by s. In the next control I'm going to be replacing as an s. So what is the input buffer contains plus id dollar. So once again plus is moved, once again id is going to be shift, but id is going to be reduced by s plus s. Now once again plus is going to be moved and id is going to be pushed into the stack. So id is going to be replaced as s as per the reduced by the production s tends to id, and reduce the production s plus s is nothing but an s, and once again s plus is going to be s. So finally input buffer contains an empty and the stack contains a start symbol. What is the start symbol here? S is we have. So this way of construction is, finally we are going to be, the parsing action is nothing but an action accept, shift action, reduce, accept. If it is any more symbol is going, if it is available, then in such case we are going to be saying that is an error. So let us consider another example. So another example I'm going to be consider as, so here the grammar I'm going to be consider as e tends to 232, e tends to 2e2, e tends to 3e3, e tends to 4. I'm going to be perform the operation for the input string 32423. So actually I have taken a stack is an empty, input buffer is 32423 dollar followed by dollar, and parsing action one, first of I'm going to be shift the 3 into the stack, 3 is pushed into the stack and the remaining input buffer contains 2423. So now once again 2 is going to be pushed, 4 is going to be pushed, 2 is going to be pushed, and then 3, like that we are going to be moving the 0 or more symbols into the stack. If you observe this 3 to 4 and 4 is going to be replaced as e, as per the production e tends to 4, we have the one production that we have, then 4 is going to be replaced as e, and once again 2 is pushed to e2. So once again, so as per the production e tends to 2e2, so that is, this is a replaceable part, this replaceable part is going to be replaced by using a e. So in the stack I'm going to, instead of 2e2 I'm going to be replacing with the production left hand side symbol, that is nothing but e. Once again 3 is going to be pushed, and once again 3e3 that we have, as by the production e tends to 3e3, the production left hand side symbol is going to be e, instead of 3e3 I'm going to be replacing with a. So that is nothing but the stack contains start symbol and the input buffer is an empty. So finally parsing action is nothing but accept. This is the way of constructing a shift reducer parser. This is the easy way of the parser. Only the only 4 actions that we have in the shift reducer parser. One is a shift, second is a reduce, third one is an accept, fourth one is an error. Shifting the symbols into the stack, that is nothing but shift operation. Reducing the left hand side symbol, right hand side symbol by left hand side production symbol, then we can call it as a reduce. And the parser halt and a successful completion, then it is called as an accept. If it is any error, then we are going to be saying that the parser does not continue with the string derivation, deriving a start symbol. So this is the way of constructing a shift reduce parser. Thanks for watching.